Hi there, and welcome to Binomial Expansion.
And why it can ruin your life.
I'm Mike.
And I'm Andrew.
Alright, let's go ahead and get started. Let's do some Algebra 2 quick review.
Any power of a binomial can be obtained from the binomial theorem.
The binomial theorem. For any value of n, whether positive, negative, integer, or non-integer, the value of the nth power of a binomial is given by
a plus b to the nth power equals a to the n power plus na to the n minus 1 b plus n times the quantity of n minus 1 divided by 2 times n times a to the n minus 2 b squared, etc.
Yeah, it looks pretty intense, but it's not. It actually makes life a lot easier. The binomial theorem is a quick way. Okay, it's a less slow way of expanding or multiplying out a binomial expression that has been raised to some generally inconveniently large power.
For instance, the expression 3x minus 2 to the 10th power would be very painful to multiply out by hand. Thankfully, someone figured out a formula for this expansion, and we could plug the binomial 3x minus 2 and the power 10 into that formula to get that expanded, multiplied out form.
Some helpful hints. It does sound pretty intense. The answer to the question, what are the binomial coefficients, is called the binomial theorem. It shows how to calculate the coefficients in the expansion of a plus b to the nth. The symbol for a binomial coefficient is n over k. The upper index n is the exponent of the expansion. The lower index k indicates which term, starting with k equals 0. The lower index k is the exponent of b.
K will successfully take on the values 0 through 5. A plus b to the 5th equals a to the 5th, and then when the power is 4, it equals a to the 4th and b plus a to the 3rd, b to the 2nd, so on and so forth, so the exponents always add up to 5.
Exactly. Again, each lower index is the exponent of b. The first term has k equals 0 because in the first term, b appears as b to the 0, which is 1. Let's go ahead and try one. Expand x squared plus 3 in parentheses to the 6th. If you've never done it before, you've probably gotten a little stuck, so let's go ahead and jump in and help you out.
The first term in the binomial is x squared, and the second term is 3, and the power n is 6. So counting from 0 to 6, the binomial theorem gives us x squared plus 3 to the 6th power equals x squared to the 6th power, then 3 to the 0 power, which just gives you x to the 12th and 1. Then, when you do 1, x squared to the 5th power, then 3 to the 1st, then x squared to the 4th power, 3 to the 2nd, x squared to the 3rd power, 3 to the 3rd, x squared to the 2nd power, 3 to the 4th, x squared to the 1st power, 3 to the 5th, then x squared to the 0 power, then 3 to the 6th.
The combination function at the beginning of each part of that binomial is basically just what we discussed in the previous slide. You are getting that exponential coefficient and multiplying it by that part of the binomial. So basically it saves you from writing each part out by hand over and over and over again and then having to FOIL that whole formula.
Simplifying gives us x squared plus 6 x to the 10th times 3 plus 15 x to the 8th times 9 plus 20 x to the 6th times 27 plus 15 times x to the 4th times 81 plus 6 times x squared times 243 plus 729.
And simplifying again arrives us at the answer x squared plus 18x to the 10th plus 135x to the 8th plus 540x to the 6th plus 1215x to the 4th plus 1458x to the 2nd plus 729. You can see the descending order of the exponents as they would in a normal binomial. Now imagine actually multiplying that out by hand. You'd probably be doing it for at least an hour. Thank you for listening. This is Mike again, and this is Andrew, and you've just watched Binomial Expansion.
Have a nice day.